So the theoretical lenses we choose to look at the interaction between students and memes are the boundary object between social media and mathematics, the cognition framework, looking at memes as visual mediators, and the role of emotion in learning. Hopefully, the memes can act as gateways between emotion and cognition. And our research questions are, do memes act as boundary objects when we use them in a school context? Can they be identified as part of a mathematical discourse? And what is the role of creativity and emotion in a learning process involving memes? The building of a teaching experiment was a challenge because it is a totally uncharted field and has to be built from scratch. So we decided to have students create memes, but we wanted to make the mathematical content more evident. So we decided to pair the meme with a video and a GeoGebra applet with a symbolic or graphic representation. With this setting, we performed a number of teaching experiments, and we collected data about the products. You see memes, video, and in one case, GeoGebra applets, and about the processing, both the creation, processing, and the discussion about the memes, and student impression, which were gathered with questionnaires before the activity, after the activity, immediately after, and 2 months after. And here you see some examples of the production of the meme created during these experiments. You see the teacher training one is focusing on one typical mistake, and the students created one are slightly different, so it's a lot of things going on there. And what we found out at the moment, looking at all this data, is that memes convey a number of layered meanings. So we imagined a sort of construct of partial meaning that is needed to understand a meme. And the first meaning is structural. I mean, you have to recognize it as a meme. And this meaning is carried by the graphics, the font, the composition. The second partial meaning is social, and it's carried by the image or the syntax. And the third is specialized, and it could be carried by symbols, text, or graphics, or whatever, and it focuses on a specific topic. If you don't get one of these partial meanings, you miss the full meaning of the meme. And the other evident findings we came across analyzing our data is that really students enjoy them, enjoy the creative part. You see, these are the answers to the evaluation questionnaire of the 10th grade teaching experiment. I felt a sense of freedom of expression while having fun, but also learning and helping to remember math topic better, and a different approach to mathematics, which is significant. And the role of emotion, because they liked it very much, and they imagined that having created a meme would have helped, could help them remember the topic better. So with this data, we gave our small contribution to the literature about the memes in mathematics education with 2 conference papers, which were presented at SEMI and at PME in Utrecht and in Moscow this year. And the last reflection we made is that looking at the interplay between students and memes, I think we can welcome memes as inhabitants of the semantic realm of mathematics, because students look at meme and decoded the mathematical part immediately in a process that resonates with the idea of Duval conversion. And if it is so, we think that really memes can have a cognitive implication, because the conversion is one of the key activity to really grasp a mathematical concept. So memes can be used to augment the variety of semantic representation of a mathematical concept, to enrich a mathematical lesson, but of course they are not enough. We are aware of that. And thank you.